Please.
Okay, nice one, thank you. Okay, so we want to talk about edge computing and synchronization. And you may or may not be aware today, about 90% of enterprise data is being sent to the cloud. This number is supposed to drop to just 25% in the next couple of years, according to Gartner. Now, where's all of that data going? It's going nowhere. It's being stored and used on the devices it was produced on. For the room here, that's probably first that comes to mind is a smartphone, but obviously IoT is rapidly growing, and there are all kinds of devices, a smart coffee machine, a car, whatever, railways that want to store and process data. And that's called, edge computing. And that's our definition. It's a very simple definition. I think, generally speaking, it works. But edge computing, the term and the terminology around it, feels, if you're into the field, a little bit like this, if you're aware of the movie. So we saw all kinds of edge consortia emerge in the last couple of years, and everyone has their own definition, widely overlapping, sometimes even, like fog computing, edge computing, mist computing, and you can use it all interchangeably, and everyone wants to set their terminology as the new standard. So that's a little bit ridiculous. Generally speaking, I think it's very fair to say that mist computing is always put at the farthest out in the field. That means like small devices, generally speaking, no operating system, small sensors that basically just capture data and push it on. So that's mist. It's the smallest you can get, generally speaking, no operating system. And then in between, so for us, everything from mist to fog here is edge computing. But depending on the definition, edge is where it gets a little bit bigger, like Raspberry Pi size of type of device, IoT gateway, it already has an operating system, so you can make them smarter. And then there's fog computing, which is used a little bit more as a central instance that distributes to other IoT gateways and makes that more from an infrastructure point happen. And then obviously I think cloud, everyone agrees, it's the big central units and all the big players you are aware of. Now edge computing is a completely new term, right? We all know. Obviously it's not. It's been around forever. It's basically history repeating itself. We came from mainframe servers, and then we went to a client-server architecture. Then with mobile, we had the cloud, which again moved more into the centralized direction. And today, the new paradigm or paradigm shift happening is edge computing. So the big question would be, why now again? So there is an underlying mega trend, and it's basically, as we all know, hardware is getting cheaper, is becoming more capable, and data volumes are growing. So data volumes are growing by just because people want to do more stuff. They have more sensors gathering data, and they want to predict more. We have artificial intelligence, virtual reality, all kinds of these things that also need a lot of data. So data volumes exploding, basically, which means part of the reason is new use case and obviously rising requirements. You all do apps, you all deal with customers. Today, an app needs to always work seamlessly. So one requirement people have is offline functionality. And to me, offline functionality really is much more always on than really offline, because it works all the time. When you think about it, when you are mobile, whenever you are mobile, at some point you will be offline. It's just a given. And then we have certain settings. For example, the factory floor, which is very interesting when you go to IoT, where you just often don't have connectivity or very expensive or unreliable connectivity. But if you depend on an internet connection, you don't know when you have it, how good it will be. It's just no guarantee. Unfortunately, you users don't care if it's the network or what's not working. They expect your app to work. I think there's nothing worse than the user experience of having a new app, and if it's fully cloud-based, it doesn't even load. You can't even look at anything. And usually for 90% of apps, there's a lot of data you would not need to get from the cloud, right? So why not enable your users to use it when they want to use it, when they need it, with what's possible, with what makes sense. It depends on the use case. And then, as I pointed out earlier, we also do a lot in IoT. In the industrial world, it may be very important and crucial for the business case that devices can take autonomous decisions. For example, if it concerns worker safety in a factory setting. For the app developers, otherwise this is happening, because if your app doesn't work well, today people are really fast in giving you bad ratings, or just uninstall the app. To be successful on the App Store, offline first basically is a value proposition for your users. Data security is another reason why edge computing becomes important, why people want an offline capable app and want the data on the device. Actually, there have been studies, and it's just an example because there are several studies out there that show for people data security and security matters a lot. It's one of the highest rated features when rating an app or evaluating an app, so it makes sense to take care of it. Now, why is it safer if you have it on your device? Data that you don't send over an internet connection, data that you only store locally, is much less susceptible to be hacked. And then also think about it. If you want to go to hack data, a central server that has millions of data is much more attractive than a singular device. That would probably be very special reasons if you would go for that. And then we have seen a lot of stuff happening. So privacy and security important to a lot of people, and privacy especially. If you think about it, and it depends on your app and the case, obviously, but if you think about it, if you keep your data with yourself, with the user to whom it belongs, you don't even need to worry about data privacy. It's your data. It stays with you, no questions, no discussion, so it might make sense depending on the app you are doing. Need for speed. Okay, people always want things fast. Today, even more so. Because if you think about it, it's like telling a joke and getting this reaction. Oh, no sound. But he finally laughs, and it's super painful. And the cloud just adds latency. It's out of your control. You don't know when it's fast. You might have a special use case, for example, games, but also especially in safety, security, and health, where you don't have the luxury of being dependent upon a latency. Cloud costs. Cloud costs just can kill any project. This is especially true, like, for example, we have talked to quite a couple of people in the IoT space, and they started cloud-based. It's super easy to set up. It's, I think, for prototyping or for showcasing something very simple and fast. You don't need to care about the servers and the infrastructure and downtimes, etc. And then a couple of €100,000 per month cloud costs killed the project. It's a very good reason to move to the edge. And the bandwidth cap. Yes, there is a bandwidth cap, especially if it depends on the areas, but in the cities with IoT devices and apps rising, there is a bandwidth cap. And obviously you need to take care about that. It's something that concerns us all because it's just a true limitation. And new networks like 5G and generally the network capabilities cannot be expanded as fast as the need for growing data volumes is expanding. So that's a real limit we are facing at the moment. And then typically people say, but what about 5G? Yes, obviously 5G will help. Still, when you're mobile, you will lose connectivity at some point. You will never have the guarantees. And basically, all that happens is it's an amplifier, because people just want to do more. They want to track more data. They have new use cases. They want to do edge AI, machine learning, etc. So I think this is just an enabler of edge computing and a part of it, but it's not a reason to think it will solve any of those bandwidth cap and speed issues, really. Yes, and obviously privacy and security anywhere. So is the edge eating the cloud? Obviously no, we're all a big happy family, and I think I pointed it out indirectly. While you can process more data faster on one device, you can take autonomous decisions, data privacy, security are advantages, cloud costs go down. Usually you want some parts of the data in a central instance. It may be a central dashboard, it might be to compare stats in a game or whatever. So there's very often in the app environment a reason why you want part of the data synchronized and stored centrally, and we believe this will always be a mixture.
Right. So it's a lot of data, and having the data where it should be, where you want to work on. And data synchronization is what we refer to as a generic approach to this, like solve this once and use it in all apps. A big part of that is also that you have offline support. And if you're not connected, like the data synchronization will just queue up data, and once you're connected, it will send it out. And also, because it's a good solution, sophisticated solution, you can also do delta synchronization. So efficient protocols. And of course, conflict resolutions. If you have multiple clients changing the same entity, that might require some additional effort. So how do we do this? So a lot of projects are using REST-based APIs or GraphQL. So it's sending JSON data back and forth. In IoT, it's also MQTT, publish subscribe protocol. But it's also just part of the solution. So you still have to think about how do I store the data that I'm getting back from the back end locally on my mobile, for example. And because you're doing this from scratch, you don't do sophisticated delta synchronization usually, but just, hey, give me the new data, and I will every time I will store it into the database. So you can do this with do your own, with one of those technologies. But there's also those cloud-based data synchronization solutions, and also more centered on the edge, like we are with Objectbox. So those edge-focused solutions can also have gateways, something you have on premise or server. But let's quickly look at Firebase or Firestore. So it's a cloud service by Google, and it's very JSON-y. So Firebase started with a real JSON document. Firestore is a little more flexible, but the structure is very similar. And actually, Firestore is a Firebase 2.0. It has better performance, more features, and it's more scalable, for example, queries and regions, so multi-regions and so on. When you look at edge support, it offers a cache, but it doesn't guarantee you what data you have cached. It tries to do it well, but if you want certain data to be really here, it just doesn't work. So it's really a cloud-first, cloud-centric solution. So if you look at alternative approaches, could Git, for example, be a good inspiration for that? Let's look at that. So it's more decentralized, and it has a more complex history, right? So there are branches and merges And sometimes you have to do something with merges, like resolve conflicts. Sometimes they just work. And also like this chain of cryptographic hashes. So each commit, the content is computed to a hash and also applied with the previous hash, so you have a good security here. So, and when you transfer this to like data synchronization, let's say these are like data states of your app on, and if you have like another client that is like disconnecting here, it will have new data, so it will branch. And there could be another client also editing data, but at some time you want to reconnect to the server, and then the data is applied to the backend, and the same thing with the other client. So this works kind of like a Git rebasing, right? And this is like actually the inspiration for Objectbox. So each transaction, like a database transaction, is a state transition from one state to another. And those actions, it's like a transaction log, right? So from one state, you can, just like Git, take the content of the transaction log, combine it with the previous hash, and then you have a new hash, and this is like the transaction ID. And again, you have like a chain of history. And this allows delta synchronization, basically, because clients can come to the server and say, here, this is my last transaction ID. And then the server will just distribute from the data from there. So when you look at the API for sync, so with a standard Objectbox, no sync involved, you always need a store. And then you need to create a sync client. So yeah, you tell this server where are some credentials, probably not this one in production. You can have a listener and so on, and you build it. And then all you do is nothing more. So this is standard Objectbox. So you get a box and you put an object in. And this object is stored locally, but also synchronized to the server and to our clients. And we have a demo at our booth, so please check it out. And we are also accepting like alpha registrations right now. Okay, this is our short talk. Thank you very much.
Questions? Questions?